Hello and welcome to presentation 4 of 7 of Electrical Principles and Technology, a presentation for Science 9. Electrons are bonded closely to the nuclei, allowing little movement in insulators, while in conductors, the electrons are free. When electricity is added, the electrons move towards the positive terminal. So here you have a good conductor, electrons are moving. Here you have a semiconductor, some electrons are moving, and an insulator, no electrons are moving. Semiconductors are almost perfect conductors. They have almost no resistance to electron flow. The largest obstacle to making these widely available is to find a way to get the semiconductor to work at a reasonable temperature for everyday practical applications. They tend to heat up. A gas can act as a conductor in the same way as a wire. It conducts the flow of charged electrons from the negative terminal to the positive terminal. Gases usually insulate, but some gas atoms can be excited by electricity and can act as conductors, including neon, which gives a pink-orange light, neon and argon, which give a purple light, and helium, which gives a yellow-white light. Neon signs have electrical technology applications. First, electricity must travel all the way through the tube in order for the gas to glow. Second, the sign has to have a control to turn it off and on. Third, the sign must be safe. Resistance. A special type of conductor called a resistor allows electrons to flow but provides some resistance. Resistance is a measure of how difficult it is for the electrons to flow through a conductor. It is measured by ohms. The more resistance a substance has, the greater the energy gain it receives from the electrons that pass through it. The energy gain is evident in heat and light energy, light bulb filament, or the wire in a toaster. A switch is a device that allows the flow of electrons to stop or start. When the switch is open, there is no flow because there's a gap in the conductor. When the switch is closed, the switch becomes the gap replacement and allows the flow of electrons to continue. To change the electron flow gradually, a variable resistor or rheostat is used, a dimmer switch with a volume knob control. Solutions can also be resistors. Lie detectors are also a special application of resistance within the body. Skin resistance, blood pressure, and respiration. An increase in stress usually associated with a lie will improve conductivity and show a peak in the recording device. Modeling electricity. Voltage. A waterfall is used as a model to demonstrate voltage. Water flows when there is a change in the gravitational potential energy or elevation. Electricity will not flow unless there is a change in electrical potential or voltage. Resistance and current. The flow of water in pipes is used as a model to demonstrate resistance. The size of the pipe determines the volume of water allowed through it. The amount of resistance in a circuit determines the size of the current. Ohm's law. George Simon Ohm, a mathematician, proved a link between voltage, current, and resistance. The unit of resistance was named after him. It's called the ohm. Ohm's law states, as long as temperature stays the same, the resistance of a conductor stays constant, and the current is directly proportional to the voltage applied. So, resistance is equal to voltage divided by current if the temperature stays the same. Applying Ohm's law, if the temperature of a resistor changes, the resistance changes as well. The resistance is usually low when the resistor is cool, and as the temperature increases, so does the resistance. Measuring electricity. Voltmeters measure voltage difference or voltage drop. Ammeters measure current or flow rate in amperes. Small currents are measured using galvanometers. Multimeters can measure voltage, current, and resistance in a circuit. Types of resistors. Different resistors are used for different applications, especially in electronics. There are many styles, sizes, and shapes. The two most common are the wire-bound and carbon composition types.